My name is Robin Meit, and I'm a PhD student at the Department of Radiation Sciences at Umeå University in Sweden. On behalf of my co-authors, I would like to introduce our paper, Components of One-Carbon Metabolism Other than Folate and Colorectal Cancer Risk, recently published in Epidemiology. Despite extensive study, the role of folate in colorectal cancer development remains unclear, potentially either promoting or preventing cancer, depending on dose and timing of exposure. Research has therefore begun to study other components within the folate-mediated one-carbon metabolism. Our study investigated blood levels of methionine and metabolites in the choline oxidation pathway in relation to colorectal cancer risk. While folate is involved in both DNA synthesis and methylation, these metabolites are mainly involved in methylation. This was a case control study of around 600 colorectal cancer cases with doubled matched healthy controls nested within the prospective Northern Sweden Health and Disease Study. The cohort is a population-based cohort from northern Sweden with a mean participant age of 60 years old, and the population is characterized by low intakes and low blood levels of folate. What we found was that subjects with higher blood levels of methionine and betaine had a modest reduced risk of colorectal cancer, corresponding to an absolute risk difference of about 200 fewer cancer cases per 100,000 individuals for subjects in the highest tertile of metabolite concentrations compared to the lowest. This was opposite of what had previously been seen in the same cohort for folate, where instead subjects with low levels had a reduced risk of colorectal cancer. The main limitation of our work is the use of only one baseline blood sample per individual, which does not take into account long-term variations in metabolite levels over time. However, most of the metabolites have good within-person reproducibility, and our results are consistent with two previous studies on the same components. In conclusion, the reduced risk of colorectal cancer seen in subjects with higher levels of the methyl group donors, methionine and betaine, may suggest that facilitated DNA synthesis rather than changes in DNA methylation represent the driving force behind the believed promoting effect of folate on colorectal cancer development.